Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. Alright, so in this video we're going to talk about the distance formula and how to use it to find the distance between 2 points. Now what we want to learn is that the distance formula is just the Pythagorean theorem kind of rearranged. So let's look at this graph of our goal would be to find the distance between point A and point B. But anytime you have a line like that, you can draw in the length of the change in y and the length of the change in x. And in Pythagorean's theorem, we would say that this side squared, a squared plus this side squared, would equal the hypotenuse squared. That's Pythagorean's theorem. And so using that same idea, then we can build our distance formula, which would mean that we'll start with the x's. So the distance squared, so now we're going to call this the distance. The distance squared equals the change in x plus the change in y squared. Okay, so just like we had a squared and b squared, now we have x2 minus x1, which is the actual length of that side, and y2 minus y1, which is the length of the other side. All right, and then the actual distance formula goes ahead and resolves this d squared and says, all right, well, it's d equals the square root of, because remember, to solve for something squared, I take the square root of it. And so here I have x2 minus x1 squared plus y2 minus y1 squared. And that is your distance formula. So write that in your notes so you'll have it. I don't think I have like a certain spot in your notes for that. I actually redid this video, so just make note of that somewhere in your guided notes, the actual distance formula. All right, so now let's use that to find the distance between 2 points. So we'll graph this point E is at 1, 2, 3, 4, 1 right here, and point F is at 1, 2, 3, negative 1. Okay, so we want to find the distance between these 2 points, and on a graph I wouldn't have to do a lot of fancy calculations. I could just count this out, and that's 2, and this is 1, 2, 3, 4, 5, 6, 7 units. So I could kind of use it like Pythagorean's theorem and say, all right, well, the distance is going to be the square root of the length of one side squared plus the length of the other side squared, and that's going to be the square root of 2 squared is 4, 7 squared is 49, so the square root of 53, and I'd be done. However, we don't always have a graph to just count, so we may want to do it with, we may need to do it with our actual coordinates. So we can call this x1, y1, we can call this x2, y2, and use our distance formula and plug in numbers and calculate it that way as well. So x minus x would be 3 minus a minus 4, which turns out to be 3 plus 4, plus negative 1 minus 1 squared, Three plus 4 is 7, 7 squared. Negative 1 minus 1 is a negative 2 squared. Now what you'll notice here, we had 2 before when we counted, and here we have a negative 2. But these amounts are always being squared, So you're never going to actually end up with a negative number. And this, then you get the same thing, square root 53. All right, we'll do another example. Let's take this one. We're going to plug it into our distance formula. x1, y1, x2, y2. All right, so x minus a minus 5 squared, y2 minus y1 squared. 8 and 5 is 13 squared. Negative 4, negative 6 is negative 10 squared. 13 squared should be 169 plus negative 10 squared is going to be 100. And we get the square root of 269. Now, you may be asked to leave that in decimal form, so let's see what that is in our calculator. I'm going to hit 269 and then the square root button. And on this calculator, that becomes 16.4 rounded. In most cases, if you're looking for a distance, we would talk about that in decimal form. If you were asked to simplify this radical, you would have to go through the process of finding what perfect squares could be divided into that number and then bring those on the outside of the radical. But 269 happens to be a prime number, so you wouldn't find one, and this is as simplified as it would get. All right, go ahead and try on your own the next one from the points 4, 3 and negative 3, 7 and see what you get. And then we will go over that in class. All right, have a great day. We'll talk to you later. Bye-bye.